Hello to all, how are you all? Hope doing good. I am Gurmeet Singh. Welcome to CREATA Classes and also welcome to our lecture series on statistics for class 10 student. In this lecture series, we will cover all these lectures, all created using the visual tools. And check out the description for the continuing lecture and also the lectures related to other topic, including the PDF of the formula list. Okay, check out the description. So without taking any further time, let's start with this lecture. Best of luck and here is the lecture. In this lecture, we will cover the mean of the grouped data. Let's start with the lecture. In the previous lecture, we have covered the basics of the statistics in which we have covered the mean, median and the mode. In this lecture, we will cover only about the mean in the grouped data form. In the previous lecture, we have covered what is grouped data and what is ungrouped data. And especially in this lecture, we will cover the mean in the grouped data form. Basically, mean in the group data form involve three different methods. The first is the direct method and this is the formula. Second is the assumed mean method. This is the formula. And the third one is the step deviation method and this is the formula. These three formulas or these three different methods we will cover, but do not simply mug up the formula. We will go step by step, a systematical approach, why we are having this formula, when to use which formula and what is the importance of each of these three formulas. Okay, we will go in the systematical order and we will go deep into the concept. Do not try to mug up the formula. As you learn the different approaches, these formulas will come automatically to you. So let's start with the lecture. Firstly, mean. Mean, in the previous lecture we have seen mean is the average of the number series. Suppose we are having a number series, just taking the average is called the mean of this number series. What is average? Just add all the number and divide it with the total number in that number series. Got it? Mean is just the average of the number series. Let's understand it more through an example. Suppose we are having some students who got some marks in the examination. This is a table. The same table we have also covered in the previous lecture. So let's see. Here in the first row we are having the marks obtained. In the second row we are having the number of students. For example, here if we talk about this column, here one student got 10 marks. Okay. And in the second column, one student got the 20 mark. In the third column, three students got 36 marks. It means that 36 marks are repeating 3 times. 36, 36, 36. 3 students got marks as 36. Here 4 students got marks as 40. It means 40 is repeating 4 times. Are you understanding? On the first row we are having marks obtained, which are called the observation, which are generally denoted by X. In the second row, we are having the frequency. Frequency means how many times our observations are repeating. It is denoted by F. Here observations are the mark obtained and frequency is the number of students. Means how many students got certain marks. Got it? You know what is observation and what is frequency. Similarly, we can study all these columns and we will got these number series. And we have to calculate the mean of this number series. What we will do? Firstly, we will add all these numbers and we will divide it with the total number of students. And what are the total number of students? If we add all these students, we got the total students as 30. So if we add all this number and if we divide with the total number of students, we got the average, which is 59.3. That is the mean of this number series. So we can say the mean of this table is 59.3. Got it? This is the basics of the mean. That is the average of the number series. We can also do it in slightly different way. Let's see. Students, note that I am just trying to lay down the very basic fundamentals. Once our basic fundamentals are cleared, then we will go to the advanced concept. Note that we are doing in a systematical order. So just be with me. Let's move further. Let's convert this table into this table. Just we have converted the rows to the column. Now our marks obtained are in the column form and the number of students are also in the column form. Simply we have not done anything special, just converted the rows to the column. Why we have done this? Let's see. Here we have to calculate again the mean of the marks obtained. Let's denote the marks obtained as xi and the number of students as fi. X is the observation and f is the frequency. Just we have added I in the observation as well as in the frequency. I is denoting the serial number. Here if we talk about 10, it will be x1, the observation of serial number 1. Here 20, it will be x2, 36, it will be x3, x4, x5. Similarly, it will go on. I is just denoting the serial number. Similarly, it is with the frequency fi. F1 is 1, F2 it is 1, F3 it is 3, F4 it is 5, F5 it is 3. Similarly, it will go on. I is just denoting the serial number. So let's move further and let's calculate the mean. To calculate the mean, we have to add one more column. That will be fi into xi. We will multiply fi with xi. Why we are doing this? Let's see. Firstly, let's multiply each row. Like fi xi, 10 into 1 it will be 10. 20 into 1 it will be 20. 36 into 3 it is 108. Here if you observe, 36 is repeating 3 times. Basically 36 plus 36 plus 36, which is 108, or 36 into 3 it is 108. What we have done, simply we are trying to not go into all those long calculations like adding all those long number series. We are trying to find a simple way. For that we have added this new column, which is fi into xi. As we move on, you will understand it more why we have added this. Similarly, do all the calculation, calculate fi and xi for all the rows. We got all these numbers. Let's add fi into xi. The sum, which will be equal to sum of fi into xi, which will comes out to be 1779. Got it? And the number of students, the total frequency, let's add the total number of students. It will be sum of fi. We got the total sum as 30. That is the total number of students. Here our mean or the average will be sum of fi into xi upon sum of fi. That is 1779 upon 30. Why we have done this? Simply we have used the same approach we have used in the previous case. In the previous case we have added all these numbers. Here also we have added all these numbers, but in a slightly different way. If you compare both of the cases, in the first case you can see it is 10 plus 20. Here also we have added 10 plus 20. Then in the first case we are having 36 repeated 3 times. Here we are having 108, which is 36 into 3, which is 36 plus 36 plus 36. Got it? Now you can compare, both are basically the same. Further, we have repeated 40 into 4 times, that is 40 plus 40 plus 40 plus 40, which is 160. Got it? Both are basically the same, just we have added in additional columns so that our calculation can be further simplified. Adding all this number, the possibility of doing the mistake is much larger as compared to our new method, that is addition of the column. Got it? This is one of the way to find the average or the mean, that is adding a column and multiplying fi and xi, then adding all those fi and xi, getting the sum and dividing it with the total number of frequency. So we got our formula as the mean is equal to sum of fi into xi upon sum of fi. Got it? This is a simple method. Now we will move to the advanced form of the mean. The three methods that we have discussed in the starting, the direct method, the assume mean method, and the step deviation method. So these three methods we will cover. But the basic foundation is this approach, that is calculating the mean using this approach. Once you got this approach, your basic is clear. Now we can go to the advanced form. Let's see what is the advanced method. Here we are having a simple number of students and the simple marks obtained. But in the actual real life calculations or the real life scenarios, the data is usually so large and doing all this calculation became very tedious and difficult. So we have come with some advanced form of method to deal with large number of data. For that, we will go with our first method, that is the direct method, in which the grouping of the numbers comes into play. The grouping of the number we have seen in the previous lecture, in which we group the number series into certain categories or the class intervals. Let's again see what is grouping and how we do the grouping. So let's again take the same number series, the same number, so that we can compare the result of different method and see which is the more exact method and which we should use in the different scenarios. So again, we will take the same number series, that is the number of students and the marks obtained. We have to convert this number series into the grouped form. Let's do the grouping. In the grouping, we take the class intervals. Class intervals are generally the width of the number in which we group the number. Let's see. Here we are having the numbers from 10 to 100. So we will form certain groups. For example, the group from number 10 to 25, the group of the numbers from 25 to 40, 40 to 55, 55 to 70, 70 to 85, 85 to 100. Let's see the number of students. How many students got the marks between 10 to 25? Only two students. These two students got the marks between 10 to 25. So 2 will come in the number of students. Let's go for 25 to 40. 3 students got the marks as 36 and 4 students got the marks as 40. Note that here these 4 students who got the marks as 40 will not come in this class interval. They will come in the next class interval of 40 to 55. The same concept we have discussed in the previous lecture. In the class interval, the upper limit is not included. 25 to 40, it basically means 25 to 40, but 40 is not included. For this case, it is 25 to 39. 40 is not included in this class interval. The upper range of the class interval is not included in that class interval. Got it? So in the 25 to 40, only these 3 students will come. The next 4 students who got the marks as 40 will go to the next class interval. Got it? This you should know. So in the 40 to 55, these 7 students will come. Similarly, from 55 to 70, 6 number of students, 70 to 85, again 6, and 85 to 100, again 6 number of students will come. So what we have done, we have converted the ungrouped data into the grouped data form. Why we have done this? Because in the ungrouped data, we are having large number of data, which is very difficult to do the calculation. So we have reduced the number of data so that we can reduce the number of calculation. This will help us to do the calculation more easily and in the more simpler form. That's why we have converted the ungrouped data to the grouped form. So we got a new table. This is a class interval and the width of the class interval here it is 15. Width basically means the range of the interval. 10 to 25 it is total 15 number. 10 to 25 we are having total 15 numbers as the width of the class interval. 25 to 40 again the width is 15. In all these class interval our width is 15. You can take the width as 10 also, like 10 to 20, 20 to 30, 30 to 40, 40 to 50. Whatever you feel is comfortable with you. Okay. So here we are having the first column as class interval and the second column as number of students. Here the marks are in the form of class interval. We are not having the marks in the simple number form, they are in the interval form. So firstly, our first step, we will find the marks that represent each interval. Note that our next step is to find the marks of each class interval that is representing that class interval. What it means? It means that, for example, if we talk about the class interval of 10 to 25, if I ask you what is the marks in this class interval, we will say it is in the range of 10 to 25. We are talking about the range, but it is not the answer. We are saying it in the form of range. My question is, for this range, what is the marks? For that, we will add one more column. The title of the column is class marks. The range of this class interval is 10 to 25. Here we will calculate the class marks. So how we will do that? We will find the midpoint of that class interval. For example, 10 to 25, what is the midpoint of this class interval? Midpoint, it will be 17.5. That is the midpoint of 10 and 25. How we have calculated that? We have just added the upper limit and the lower limit, and we have divided it with 2. 10 plus 25 upon 2, that will be 17.5. Just we have calculated the midpoint of this class interval. Similarly, we will find the midpoint of all the class interval 25 to 40. What will be the midpoint, or what will be the class marks? It will be 25 plus 40 upon 2, which is 32.5, which is the midpoint of this class interval. Similarly, we will calculate the midpoint of all the class interval, that will be class marks. Got it? Why we have done this step? So that we can find the class marks. These numbers, or the midpoint of this class interval, are representing that class. Again, I will go to my initial question. My initial question that I've asked you is, what is the class marks of this class interval? At that time, we are saying the answer in the range form. For example, for the class interval 10 to 25, our class marks are in the range of 10 to 25. But now we can say the mark 17.5, that is the midpoint of that class interval, is representing the class marks of that interval. We have done this so that we can get some of the number which can represent that class and which we can use in doing the calculation. We cannot use the class interval in the calculation. We need some certain numbers that we can use in the calculation. Once you do all the calculations, all the questions, you will appreciate this step. One advice that I want to give to you: once do all the problem questions, all the questions of this topic, again come back to this theory part. Then you will be much better able to understand why we have done this step. Okay, just an advice, it will be really helpful to you. So let's move further. Now we got a new column in the table, that is class marks. The number of students is the frequency, and this class marks will be the observation, which is xi, the observation. This we can compare with the previous case in which the marks obtained are xi, and in this case the class marks are xi. And what are class marks? Class marks are just the midpoint of that range, which is representing that class interval. So we got Fi, that is the frequency, and we also got Xi, that is observation. Now how we will find the mean? The same method that we have used in the previous case. We will add one more column, which is Fi into Xi. Simple, the same method we have done in the previous case. Let's find Fi and Xi for each row. For the first case, 2 into 17.5, it will be 35. For second case, 3 into 32.5, it will be 97.5. Similarly, we will calculate Fi into Xi for each row. So these are the Fi into Xi for each row. Let's add to find the sum of Fi into Xi, which will be 1860. Got it? Let's also find the sum of the frequencies, that is sum of Fi's. So let's add it. We got it as 30, that is the total number of students. Let's find the mean, which is sum of Fi into Xi upon sum of Fi. The same formula we have used in the previous case. On solving, we got the mean as 62. Got it? We got the average as 62. This method is called the direct method. Let's summarize what is a direct method. In the direct method, we have grouped the data. We have grouped the data into the class intervals. We got the table in the form of class interval and the number of students. Now the next question is, we are not having the class marks, that is observation. We are having only the class interval. To solve this problem, we have used the midpoint of the class interval as the class marks, which is xi, or the observation. By doing this, we got the frequency as well as the observation. Once we got the frequency and the observation, we can simply use the simple mean method, that is calculating Fi into Xi, doing the addition and dividing it with the sum of the frequency. So this method is the direct method. Got it? One thing that you should note is that the mean that we got using the direct method is 62, and the actual mean that we got from the previous method is 59.3. We are having a difference. Why we are getting the difference? We should get our answer as 59.3, but we are getting our answer as 62 using the direct method. The answer is that we are getting slightly higher mean because we have assumed the class marks. We have calculated the midpoint of the class interval and we have marked it as xi, which is observation. Due to this midpoint assumption, we are not getting the exact mean. Got it? Still, we will go with the direct method if we are having large number of data because it helps us in reducing the calculation. Almost we are getting the same average, that is 62, which is somewhat closer to 59.3. So we will accept this error and we will go with the direct method when we are having large number of data. Got it? So this is the direct method. Let's go to the next method, which is the assumed mean method. Let's see what it is and when to use the assumed mean method. We will use the assumed mean method when the value of our observation or xi is very large. Suppose we can have a case in which the value of xi or the observation is very large, maybe in thousands. In those cases, doing the calculation became more tough. For example, we have to multiply fi with the large value of xi, then we will get fi into xi. That will also be a large number. Then we have to add all the fi into xi. That will again be a much larger number and dividing it with the total number of fi. So the calculation became much difficult. In those cases in which we are having higher value of observation or xi, in those cases we will use the assumed mean method. Let's see what is the assumed mean method. We will again take the same case. Here our values will remain the same. The observation are not much larger, but still we will use the same example to show you the implementation of the assumed mean method. And also you can compare it with the previous method. That's why we are taking the same example. Let's see. In the assumed mean method, we take a assumed mean. Assumed mean, it means out of all these observation, we will take any of the one observation, probably the middle point. Here, let's take the 47.5 as the assumed mean. This assumed mean we will take and we will subtract this assumed mean from all the observation. Let's understand this in more detail. Suppose we take 47.5 as the assumed mean. You can also take 62.5 as also the assumed mean. Just you can take any of the middle number. Okay. Let's denote this assumed mean as A. A is equal to 47.5. Now we will add one more column which we will call as DI. Which is the deviation. Once we move forward, you will understand it in more detail. Here we have taken di, which we are calling as the deviation. Now we will subtract all these numbers, that is the observation, with the assumed mean, which is 47.5. For the first case, it will be 17.5 minus 47.5. We got the value of first row as minus 30. Similarly, for the second case, we will do 32.5 minus 47.5, which is the assumed mean. We got minus 15. Similarly, we will subtract this 47.5 from all these numbers. We will get the value as di. Got it? We got a new column which is the deviation, which we are denoting as di. Further, we will find the mean of this deviation. How we will find the mean of the deviation? How we find the mean of the normal observation? We use the formula as x bar, which is the mean, is equal to sum of fi into xi upon sum of fi. Here we are calculating the mean of the deviation. We are not calculating the mean of our observation. We are calculating the mean of the deviation, which will be equal to d bar. We are denoting the mean of the deviation as d bar, which is equal to sum of fi into di upon sum of fi. Just we have replaced our observation with the deviation. In the normal case, we are using xi, which is observation. Now we are calculating the mean of the deviation, so we are using the di. Got it? The simple step, nothing complicated. So we got d bar is equal to sum of fi into di upon sum of fi. Our purpose is not to calculate the mean of the deviation. Our main purpose is to calculate the mean of the observation, which is x bar. So using this formula, we will drive our mean of the observation formula. Let's see. So d bar we got as sum of fi into di upon sum of fi. And what is di? Di is the deviation, which is observation minus our assumed mean. Observation it is xi and the assumed mean it is a. So we can replace di with xi minus a. Simply we have replaced di with xi minus a. Further, can we split this term as sum of fi into xi upon sum of fi minus sum of fi into a upon sum of fi. And what is sum of fi into xi upon sum of fi? This term, this is the mean of the observation, which is x bar. So let's replace this term with x bar. Why we have done this? So that we got x bar, that we have to calculate the mean of the observation. Further, let's take as out of this term. A is the assumed mean, which will be common in all the addition, so we can take as common from this term. Further, sum of fi and sum of fi will cancel out. We got d bar is equal to x bar minus a. From this we can calculate x bar, that we have to calculate, which is a plus d bar. And what is d bar? That is the mean of the deviation. So we got x bar is equal to a plus sum of fi di upon sum of fi. We have simply replaced d bar with the formula. So we got the formula of x bar, that is the mean of the observation, as a plus sum of fi into di upon sum of fi. This is the assumed mean method. Got it? Here we use the deviation, that is di, to find the mean of the observation. We got a big formula, but our purpose is not to derive any of the formula. Yes, no doubt we got the formula, but our main purpose is to understand the concept. Let's understand this formula so that you can retain this formula in your subconscious mind. Firstly, it is x bar, that is the mean of the observation that we are looking for. The first term is a, that is the assumed mean, which we have assumed as 47.5. Note that you can assume any of the value as assumed mean. Even you can assume 17.5 as the assumed mean, or the last term 92.5 as the assumed mean. We have taken the middle term just for the simplicity. But here it does not matter. You can assume any of the number as assumed mean. Got it? Let's move further. In the denominator, we are having sum of fi. What is sum of fi? Addition of all the frequency is the sum of fi. So here sum of the frequency, it will be 30. In the numerator, we are having the term sum of fi into di. This is a new term. In our table, we are having fi, di and xi. We are not having fi into di. For this, we have to create one more column in which we will calculate fi into di. Don't get upset, we have to create one more column. Just be with me, we are going very slowly, but believe me, your fundamental and concept are building. As we go on, your all the concept will be clear. Just be with me. Here we have to create one more column because we have to find the sum of fi into di. We are having fi, we are having di. Just we will do the multiplication, we will add, we will get fi into di. So this is the new column. Let's find fi into di. The same fundamental we have done for fi into xi. Let's go for first row. Here fi it is 2 and di it is minus 30. Let's multiply it. We got it as minus 60. Similarly for the second row, 3 into minus 15, it is minus 45. Third row, 7 into 0, it is 0. Similarly, we will find fi into di. These all will be the terms. Let's move further and let's find the addition of fi into di. That will be 435. So we got our term, that is fi into di. Let's put all this value into the formula to find the actual mean that we are looking for. On solving, we got our answer as 62, which is the same answer we got in the direct method. So we got the same answer, it means our method is correct. That is the assumed mean method in which we got our same answer. Got it? Have you got the assumed mean method? Let's do the summary. We will use the assumed mean method when the value of our observation is very large. In those cases, we will take any of the middle value of the observation and we will assume it as assumed mean, which we will denote it as a. And we will subtract all this observation with this assumed mean, that is a. Then we will find Fi into Di. We will do the addition. Now we will use the formula in which we have calculated the addition of Fi into Di, and we also know the value of sum of Fi, and we also know the value of A. So using the assumed mean, we have calculated the mean. Got it? This is the assumed mean method. This we will use when the value of our observation is very large. So we have done with this method. Let's move to the next method, which is step deviation method. The step deviation method is a continuation of the assumed mean method. In the assumed mean method, we have taken one number as assumed mean, which we have denoted as A, and we have subtracted that number with all the observations. The step up to this point is same in the step deviation method also. The next step in the step deviation method is dividing the value of Di, that is all this value, the deviation, with the class size. Firstly, let's understand the class size. After that, I will tell you why we are doing this. Understanding the basic concept is important. You must know why we are doing this. Do not blindly follow the step. You must know why we have used the deviation method. You must know why we have used the assumed mean method, why we are dividing the deviation with the class size. All these things you must know, then only you should proceed to the next method or the next step. Here we are dividing all the deviation with the class size. Firstly, understand what is the class size. The class size is denoted by h. Class size is the size of the interval. Here our interval, for example, it is 10 to 25. Here we are having total 15 numbers from 10 to 25. So the size of this class is 15 number. That is, the class size is 15. For 25 to 40, our class size is again 15. 40 to 55, again 15 numbers, that is a 15 class size. So we can say for all this class interval, we have taken the class size as 15. Now we will divide all this deviation, that is a value of Di, with the class size, which is 15. And we will denote it as Ui. So what will be Ui? Ui will be Di upon h. H is the class size, which we can also represent as xi minus a upon h. So let's divide all this number with 15. We got our numbers as -2, -1, 0, 1, 2, 3. So we got the value of Ui. We got one more column, that is Ui. Now our next question is why we have done this. Here if you observe the value of Di, here the common factor in all these values of Di is 15. So we have divided it with the common factor. This step, that is a step deviation method, will be applicable in which we are having the common factor in the value of Di, so that our calculation became more easier. Here once we have divided all this value of Di with 15, we got much simpler value, like in the term of 2, 1, 0, 1, 2, 3. So this will help us in doing the calculation in much easier form. Now the data is looking very simple, so you may be thinking why we are again going for much simpler method. We are doing this because in the actual practical cases the data may be very large and the values are also very large. We have to go for different methods in which our calculation became much easier. So now we are going into much simpler method, that is a step deviation method, in which we divide the value of the deviations with the class size, so that we got one more column which is Ui, which is having much simpler values. Are you understanding why we are doing this? To get much simpler values so that our calculation became much easier. Got it? So we got the new column which is Ui. Let's move further. Let's go for Fi into Ui. Let's add one more column, that is Fi into Ui. In the first method we have gone with Fi into xi. In the next method we have gone for Fi into Di. Here we are going for Fi into Ui. Everything rest it is same. Let's calculate the mean of this u, that is u bar, which will be equal to sum of Fi into Ui upon sum of Fi. Are you understanding this? We have calculated the mean of u. The same method we have used. X bar, it is sum of Fi into xi upon sum of Fi. D bar, it is sum of Fi into Di upon sum of Fi. Here u bar, it will be sum of Fi into Ui upon sum of Fi. So let's see how we will use this formula to find our final value of x bar. Let's see, it will be interesting. Here can we replace ui with xi minus a upon h? Let's do the replacement. Let's take 1 by h as common. We can take 1 by h as common because our class interval is same. Taking 1 by h as common from all the addition of sigma, we can take 1 by h as common. Okay. Further, let's open this term. We got sum of fi into xi minus a into sum of fi upon sum of fi. Here again we have taken a as common. Because in the addition a is repeating, it is same, that is the assumed mean, so we can take a as common. Further, let's split the term. Here we got these terms. Let's replace sum of fi into xi upon sum of fi as x bar. This is the formula of mean, that is x bar, mean of the observation. Further, sum of fi and sum of fi will cancel out. On solving, we got 1 upon h into x bar minus a. Let's remove all these middle terms. We got the equation that is u bar is equal to 1 upon h into x bar minus a. We have just simply removed all the middle terms. We got our equation that is u bar is equal to 1 upon h into x bar minus a. Our ultimate aim is to calculate the mean of the observation, which is x bar. Everything we are doing is to calculate x bar. So let's solve it. We got x bar is equal to a plus h into u bar. And what is u bar? U bar is the mean of u, which is sum of fi ui upon sum of fi. Let's replace this. So this is the formula of mean using the step deviation method. Got it? Let's use the actual value. Let's put the value and check out whether we are getting the same mean or not. Let's put the value of a as 47.5. The next step, we have to calculate the sum of fi into ui and also the sum of fi. Firstly, let's calculate the sum of fi into ui. For this, let's refer the table. Firstly, let's find the individual values of fi into ui. For the first row, it will be 2 into minus 2, that is minus 4. For second row, 3 into minus 1, it is minus 3. Similarly, we will calculate fi into ui for all the rows. So let's find the total, that is sum of fi into ui, which is 29. And we know sum of fi as 30. Let's put the value, let's solve it. We got our answer as 62. Got it? That is the same answer we got using all the method. So we can also use the step deviation method to find the mean. So let's do the summary of the step deviation method. The class interval fi, xi and di. These 4 steps will repeat from the previous method, that is the assumed mean method. In this step, we will divide the deviation with the class interval. Through this, we got the new term, which is ui, which is deviation upon class size, which is xi minus a upon h. And further, we calculate fi into ui. We got the addition, that is sum of fi into ui, and we use this formula to find the mean of the observation, which is x bar. Got it? Very simple. It is almost matching. One thing that you should notice that in the assumed mean method and also in this method, you have to take any of the observation as a, which is the assumed mean. In this case, we have taken 47.5 as a value of a, which is the assumed mean, but you can take any of the value of the observation as a. Even you can take the first value, that is 17.5 as a. The answer will not change. You can try it out. You can take any value as a. We have taken the middle term just for simplicity so that we can get 0 at the middle, a negative number on the top and positive number on the bottom. We do not want the larger value in the deviation. Once you take the first number as the assumed mean, you will get the larger value at the end. So just for the simplicity, we have taken the middle term. But you are open to take any of the value of the observation as a. The answer will not change. You can try it out. Okay? So we have done all the 3 methods of the mean, the direct method, the assumed mean method, and the step deviation method. Now you know how we got all these 3 formulas. Okay, got it? These are the formulas. In the next lecture, we will cover the questions related to these formulas. So do not miss that lecture. So students, we have done with this lecture. Hope you have enjoyed the lecture. If so, please like, share and subscribe. And also check out the description for various resources related to class 10th, like the continuing lecture, the lectures related to other topics, and the PDF of the formula list. All this in the description, check it out. So that's it for this lecture. Thank you very much for being with CREATA Classes. Have a great day. Bye for now.